201. We're going to be covering some of the more advanced topics in this particular workshop. We did cover a lot in Digital Forensics 101, so we don't have too much left to cover. We just are going to go over some additional things that are good to know and some additional problems that we didn't cover last time. But before we get started, I have some important announcements. So next week, there's going to be a workshop on jobs in cyberspace. There's going to be panelists who work in the industry, and it's a great opportunity for students to see, like a career, the types of career that you can have, to ask questions about jobs in the cybersecurity industry. But for this workshop, you will need to register. The teachers and all the students will need to register. So after this workshop is over, I will be sending an email to all of the teachers and supervisors and the parents with the link to register for that workshop. So all of the teachers, supervisors, and parents, please forward those links to your students or to your kids so that they can register for the workshop. It is an optional workshop, but it will be next week. After the week after next week, we will again start up with our regular workshops, and that workshop will be on reverse engineering. So make sure that you register for that workshop next week of jobs in cyberspace if you want to attend. February 16th is when the competition registration begins. So far, if you registered on the picoctf.org, there was a guide that was sent out to the parents, teachers, and the supervisors. So if the parents and the teachers and supervisors, please pass that on to the students and the people who will be participating in the challenge to make sure that all of the students are registered on the picoctf platform, so that when it comes time to register for the competition on February 16th, we already have an account and we can, and it's easier to participate. So those are all of the announcements. Like always, if you have any questions during the workshop, please send them in the chat box. Please select all attendees or all panelists, and we will be able to see your chat. Madison Henry is going to be here for technical support. So if there's any technical issues or anything she can help you with, you can feel free to send her a message or send a message in the chat box. Yeah, so let's get started with Digital Forensics 201. So we're going to do a quick Digital Forensics 101 review. We're going to talk about what tar files are. We're going to talk about T-Shark, which is a command line tool, the same thing as Wireshark, but you use this on the command line. And we're going to talk about SSL dump. So let's review Forensics 101, Digital Forensics 101. So what exactly is digital forensics? So digital forensics is collecting, examining, analyzing, and reporting digital electronic evidence. Basically, the goal of forensics is to reconstruct prior events to find out what happened. For example, if you can analyze a hard drive, you could see what happened on the hard drive, what files were on the hard drive. You can analyze a memory dump to see what happened on your computer if there was an attack on your computer. In CTF challenges, you will be asked to analyze files, file formats, extensions, memory dumps, packet captures, and files, including hidden data, also known as steganography. And we talked about steganography, file extensions, file format. We also talked about memory dumps and packet captures. We covered all of the bases in the 101 workshop. So if you haven't already watched the recording for that 101 workshop, it's really important that you do so to get a good understanding on how to solve these challenges. So, there is a digital forensic scientific process, and that scientific process that NIST, the National Institute of Standards and Technology, recommends, and that when you're going through digital forensics, you have collection of evidence, you examine the evidence, you analyze the evidence, and you report the evidence. A lot of time, digital forensics is used and crime. So just like forensics, that's not digital. When there's a crime, there's a forensics team that goes to the crime scene to analyze the crime that took place. The same thing happens in digital forensics. When a crime takes place, like maybe a ransomware attack or any sort of cyber attack, you collect your evidence. You're going to examine it, and that evidence, there might be physical evidence like a computer, hard drive, but there's also going to be a lot of digital evidence like files, logs. There's going to be a huge plethora of things that are included in that evidence. You're going to have to examine that evidence. You're going to have to do an analysis and reporting. You can report to the authorities. You can take it to court. And also you can, report it to upper management and the directors. It's important that this process is followed because when you want to take this to court, if a cybercrime has taken place, it's really important to have good evidence and have good analysis of that evidence. So let's talk about order of volatility. We talked about this last time. So when you're capturing evidence and you're making, you're copying the data over to collect for evidence, it's important that more volatile data is acquired first. And that's because volatile data can be lost if not extracted correctly. So an example is memory. Memory is volatile, and if the computer is shut down and unplugged, then a lot of important data could be lost. So you got your random access memory, which when a computer is shut off, it resets, so you're going to lose that. There's registers, there's your cache, which talks about, which would have the next task that the CPU was about to conduct. And we talked about this in reverse engineering and binary exploitation. So if an attacker was about to, conduct a buffer overflow attack, and you weren't able to capture what was taking place on that cache or the CPU, and you shut down your computer, that evidence might be lost. So here's some order that's followed when collecting data so that the data that is important is not lost. So we've got our CPU cache, our registers, we've got data stored in the RAM, we've got files written to disk, and then hard drive is the least volatile because it's sitting there with all of your files. It doesn't, if you turn off your computer, the hard drive is not impacted. So you can capture the data from that, last. So when you're collecting evidence, here's some evidence that you would need to collect. You would need to, get the RAM, what was happening at the computer, what was it working on, capture system images. You need to do a bit by bit image of the drive to make sure you capture everything, network traffic and logs. And we looked at network traffic when we were taking a look at the Wireshark packet captures last time. And screenshots. So some things you might not be able to reduplicate on your screen. So there's different types of attacks, and then one of lots of attacks, there's usually a pop-up. So when you see that pop-up, you might not be able to look at it again. So when you see that, it's important you screenshot it to make sure that you're able to present that evidence. Hashes, we talked about hashing and cryptography, to prove the integrity. When you capture all of this data, you have to or before you capture all this data, you have to take a hash of it. And then after you capture, you also have to take a hash of it to make sure that you haven't changed or manipulated anything. In the courtroom, when you're presenting digital evidence, it's really important that the integrity is maintained, and that's proven through the hash of the files of the hard drive or whatever you've collected as evidence. So, in these challenges, there's going to be some different sources you're asked to examine. And that source could be metadata. We looked at some challenges that asked you to examine the metadata of certain files that had certain hints in them, right? Because if you don't erase the metadata, it can have important information like when the file was created, who created the file, and lots of other things like the camera, the model of the camera that was taken, if it was an image. There's a lot of important information stored in metadata. We also have your storage. So we've got desktop and laptop, hard drives, external drives, USB drives. We've got our hardware and operating systems, our networks, our applications. We have our memory images. We've got our logs that, monitor everything that's happening in the network. We've got deleted files. So deleted files don't actually get deleted because there's residual data of deleted data in what's known as slack space. And then, that free space may contain data and evidence. And so that's why it's really important to do a bit by bit image, because the hard drive has slack space and free space. And when you do bit by bit, it captures all of that could have been missing if you didn't do a bit by bit image. So let's take a look at tar files. So you might be given a tar or a zip file for a challenge. And in Pico CTF, they decided to give us a tar file. So tar file stands for tape archive file. And it's similar to a zip file that's used for archiving and sending multiple files over the internet. So you might receive, like a zip or tar, and you have to untar or unzip it to see the what data contents are inside there. And to archive a tar file, this is the command you use. It's not this, it depends on the conditions. So for X, it's instructing tar to extract the files from the zip files. So this, you would definitely need X. Verbose means to list out the files it's extracting. Z instructs tar to decompress the files. Without this, you'd have a folder full of compressed files. And F tells tar the file name you want to work on. So let's take a look at our challenge, one of the challenges, which was called like 1000. And I'm going to be using, so everything that I'm doing today, you can replicate on your, in the web shell provided to you by picoctf. So everything that I will do today, you will be able to replicate in the web shell, either using this shell or the one on this web shell right here. So let's get back to the problem. So what I'm going to do is I'm going to copy the location, the link address, and I'm going to go and open up a shell. Okay, so what we're going to do is we copy the link address, and you can do this in the picoctf shell. So we're going to use wget, which allows us to download files. And we're going to paste the location, and when we paste it, it's going to get the file for us. So it's gotten the file for us. So now we should have this. Oops, well, I've solved this problem before, but now we have this 1000.tar.1 file. So we can tar this file. We can do xf, and we can do 1000. What was the file name? 1000.tar.1. Oh, how can you find the web shell? So the web shell is, so it depends on what you're using. If you're using this 2019 platform, the web shell is right here. You're going to have to log in with your credentials. And this one, you can CD into the problem because this is the server where it's hosted. If you're using this shell right here, this web shell, you're going to have to use wget to get the files because the files that are on that 2019 server are not on this server. So you can use both shells. You can use this shell or this shell. For me, these shells are buggy and they cause delays, which is why I'm not using them to demo because I don't want to, waste everybody's time. So I hope that answers the question. So we're just going to extract, we're going to extract all of the files that are in this. So if we hit ls, now we should have the files. The problem is that I have done this problem, so it's not really doing it justice. But basically what happens is as you start extracting the file, you're only going to extract one file. It's going to extract 999.tar. Then when you extract it again, it's going to extract 998.tar. Then when you extract it again, it's going to extract 997.tar, 996, 995, and so on and so forth. So what you want to do is you want to script and automate the process so that you can, it looks like there's 1,000 tar files so that you can, untar all of them at the same time. So their script for that would look something like this using Python. So for I in 1000 to 1, do tar, so it's basically automating the process. So, untar all of the files from I to tar. So basically it would go 1 to 1.tar, 2.tar, 3.tar to 1000.tar, and then, show us the done message. So let me try copying this and running this script. I'm going to run it. It should, so as you see, all of these files are now untarring. Because if you had to do it manually, you would have to do everything one by one. So we've created a script to automate the process. And so I'm going to let it run, and it's going to untar for us 1,000 files, which would have been a pain to do manually. This can take some time depending on the speed of your computer. For me, on the picoctf web shell, it takes longer. So I decided to use this shell. So again, so after copying the address, so this is basically it's untarred all of the files. So after copying the address, let's go back up. Take some time. Not letting me. Okay, well, it's okay. We can just repeat it. So clear. Let's make it nice and clean. So after you copy the address, this you're gonna untar the file. So you can use xf, xzf, like depending on the slides that we just did, what you're trying to do, which is listed right here. So this command helps with that. X instructs tar to extract files from the zip file. V means verbose to list out the file that it's extracting, and because we selected V, it was listing them out. Z instructs tar to decompress the files. Without this, you'd have a folder of compressed files and tells tar the name you want to work on. We didn't do the Z option. Okay, let me just answer these questions. So how can I find the shell in Kali? So I'm using Kali right now. In Kali, you have your terminal, and that's where you would use this shell. Unless you're trying to use a picoctf shell, which would be available on picoctf.org. The 0.1 is because I already did 1000.tar. You don't need it. Because I'd already done this problem before, when it downloaded this file again, it appended the 1 to it. That's the only reason the .1 is there. So after you do that, you run the script, and after you run the script, all of your untarred files should be listed. When you look at the data, all of the data that was unlisted, there's also going to be right here, a flag.png. So you're going to need to open that flag.png. I'm going to use Ristretto. Depends on what computer you're using, and you might have a different image viewer. So when I hit Ristretto flag.png to open it, I get the flag, and it's lots of tars. That's the flag. So that's how you would solve that problem. There's other ways to solve the problem. Some people wrote Python scripts. I found that version was the best way, because you're just telling it to go through the first file to the 1000th file and untar them all. Saves you the time of having to do it manually, and allows you to get that flag. So let's go back. So that was how to solve it. When we're going to post the files, this is the script that was used. So you can try this out with this. Basically, again, let's go over the script. It's saying for I in 1000 to 1. So basically from 1 to all the way up to 1000. So it would go through 1, 2, 3, 4. Do tar xvf, which is extracting the tar files, listing out the files, and you have to use F to tell the file name you want it to work on, which would be 1000.tar. You're going to do that, and when that's all been done, you're going to hit done. I mean, it's going to give you a message that it's been completed. So that's the script that was used for this. So now let's move on to another problem. Let's talk about network traffic. We talked about network traffic last time. So computers need to communicate with one another, right? So a computer network is 2 or more computers that are connected with one another for the purpose of communicating data electronically. Right now, my computer is connected to all of your computer, and our computers are generating some sort of network traffic between us. And this was from Britannica, the dictionary, this definition, but it's pretty standard definition. In digital forensics, you have to analyze network traffic and data captured in transit between devices. So for example, if we have logging set up, my logs would be analyzing and logging the network connections that I'm making. So it'll be logging all the connections that are being made out to speak to your computers, and it would all be in the log. And if there was anything suspicious that happened, I could later take a look at it and analyze and see what's going on. So network data can be collected from firewalls, switches, network logs, routers. And some tools that we can use to analyze network traffic is Wireshark, TCP dump, and Tshark. So last time we used Wireshark to demonstrate these problems. If you can get Wireshark, then by all means, download it. It's a great tool. It's used in the cybersecurity industry. Professionals use it. So it's a great tool to have exposure to and use. It comes pre-installed on Kali Linux, but if you don't have access to Wireshark, you can use TCP dump and Tshark, which are command line tools. So let's talk about networking protocols, and we're going to get back into Wireshark and Tshark. So networking protocols are rules, and they're a set of predefined rules that allow computers to speak to one another. And 2 key protocols allowing this are TCP and UDP. So UDP, we're probably in video chats, it's often a UDP connection when data is transmitted without a connection being established. Common applications are video chatting, online gaming, and it's a fast connection. So to connect to your computer, for UDP, I wouldn't need to set any connection. I would just send the data. I would just send you data, and if you receive it, if you don't, then you don't. In UDP, you can't trace back if the data was received or if there was any errors in it. You just kind of send it. So UDP is kind of like, I saw this example and I really loved it. It's like shouting at someone and you don't know if they heard you or not. You're just shouting things to them and you can't really tell if they're hearing it or not. You're just shouting at them. TCP is actually, it's, a transmission control protocol. And to set up a connection, you have to perform a handshake. So what happens is if I want to talk to your computer, I have to send your computer a packet, a synchronization packet. If your computer is allowing you to talk back, it's going to acknowledge that packet and then send me another synchronized packet, and I'm going to send it an acknowledgement packet. And then we have established a connection and we can communicate. So this is like when I want to start a conversation to you, I come up to you and I say hi, and you say hi back, and I say, can we start talking? And you say yes. So UDP is like shouting at someone, and TCP is when you have a conversation, you go up to someone and make sure they want to talk. So that's the difference between TCP and UDP. And TCP takes longer. So, it takes longer, but UDP is fast. But TCP is reliable because it will tell you if your packet was received by the other party. If data was lost, it can get retransmitted. If a packet was corrupted in transit, you can resend it out. So we talked about Wireshark last time. We actually looked at an example. So Wireshark is a protocol analyzer. It's a network packet analyzer that allows you to see recorded network traffic. And this traffic is stored in a PCAP file. The packets are, data that's transmitted over the network. This packet contains data and other important information such as destination IP, source IP, and lots of different things based on the headers. We talked about Wireshark last time, so we won't go into detail, and we actually did a demonstration with Wireshark too. So if you're interested in learning more about Wireshark, please watch the 101 Digital Forensics recording. That's on the Resource Hub now. So this is what Wireshark looks like. This is the thing with Wireshark is it offers you a graphical user interface. You can actually see the packets. It's not command line, which is, some people who are visual learners, it might help them to visualize packets better. You can follow a protocol stream to see all the data that's generated through the network. You can follow a stream to see exactly what happened in that stream. So if you want to practice with Wireshark, you can go to wireshark.org. You can download it there. You can, there's some packets on their website, PCAP files that you can analyze for fun. But what we're going to be talking about today is called T-Shark. T-Shark is a terminal-oriented or command-line version of Wireshark designed for capturing and displaying packets, but an interactive user interface isn't necessary or available. So for many of us, T-Shark is not going to be, T-Shark is going to be the go-to if we don't have access to Wireshark, and T-Shark works great. It's just the command-line version. So how is it used? So the commands are just tshark.i, the capture interface, -f, the capture filter, -2, -r is the file. So if I want to take a look at a file, I would do tshark-r and then the PCAP file. If you wanted to go into an out, like if you want to record all that data into a text file, you would do -w out file. You would specify more options, filters. That's how you use it. It's a little bit tricky. You have to really have good scripting knowledge, and you have to be able to comfortably script using Python and to be able to comfortably use T-Shark or TCP dump. Whereas Wireshark offers you a graphical user interface, so you can just go and interact with the graphics. So let's solve a Shark on Wire 2 problem using T-Shark. Let's try Shark on Wire. Are these all of the? So I'm going to again copy link address. You can solve this problem in the web shell. To install Wireshark or T-Shark, you would do sudo apt install T-Shark or sudo apt install Wireshark into your web shell. Okay, so we're going to get the packet capture file. We're going to paste selection and hit enter, and we've downloaded the file, so we should have capture. Okay, we really got to remove these files out of here. You know what? Let's make a new directory. Let's call it PCAP. So let's cd into pcap, and let's get the file again into here, just so it's neater, so we don't have all of those files. So let's list it out. So now we have our packet capture. Much easier to see. So where were we? Okay, so now we're going to try looking at this. So we would do tshark -r capture.pcap, pcap, and hit enter. So this is basically the command line version. So here's all of the kind of the packets that are taking place. So we see there's a lot of ARP, there's a lot of UDP, there's a lot of TCP. Here's some UDP. This is ARP, which is Address Resolution Protocol. So we know that's not important. We're going to work with TCP and UDP. The thing with TCP is I don't see any data in this. So let's keep going up. So what you would be doing at this point is you would be analyzing each of these packets. So I see a lot of UDP packets. So let's just take a look at just the UDP packets. I don't want to look at all these TCP packets. So let me just, so tshark -u -capture.pcap -y UDP. Let's just take a look at UDP. And there's a lot of data in there. So again, this is why it's a little bit tricky working with tshark, because you really have to know how to like manipulate or script so you can better read the data. So there's a lot of UDP packets here. So it's a lot. So honestly, like this is really hard to read. So here we have our source port, we have our destination port, we have our length, checksum. Some of it will have data too. Let's see. Let's see if we can see one that has some data in it so we could see what's inside. So here's some data, 616161, and in ASCII, that's AAAA. So right now we're viewing the data in hex, and that's AAAA. Doesn't look like a PicoCTF packet. So there's going to be a lot of analysis in this part. Again, AAAA. So what I will do is I will see if I can grep. So what I do at this point is it's because it's in, why do I always do that? Because it's in ASCII, or in hex, I want to do ASCII to hex converter and see what's going to happen. So let's go here. And I know in my flag, there's going to be this. So let me just convert that into hex, and that's 70. So let's go back here and let's grep. Oops, did that by accident. Let's grep for 7B to see if there's any packets. Yeah, so I found some 7B packets. So, you know, it's saying 7B A3, copy selection, and let's do hex to ASCII, see what that translates to. Okay, so it looks like, you know, that could be a flag. So anyways, this analysis took me some time. I went through, I looked at P, I, C, and then I found the packets. And what I found was that all of the, in UDP, all of the destination ports with 22 were receiving this flag. We're receiving the PicoCTF flag, and the source ports were greater than 5,000. So if you look through all of the packets in tshark, you're going to notice that pattern. So then we wrote a script like this, and this is not my script, it's linked in the resources. So you can use a script like this. You could write, and to use a script, you need SCAPI. SCAPI is a script for analyzing, you know, PCAP files and network traffic. So to make sure this script works, you have to download SCAPI into the web shell from GitHub. If you want to use a scripting method, but I'll show you another method. So what the script is saying, it's saying that packets in the capture PCAP file, the flag, this is the flag, and the flag is equal to, for P in packets, if UDP is if the packet is a UDP packet with a destination port of 22, and if the source port is greater than 5,000, then append all of that data from this source port to up to 5,000, and then print all of those characters together, and that will be your flag. So basically, it's a little bit complicated, but that's what the script's doing. It's taking all of that output, combining it, and printing out the flag for you. What we can use is we can use some shell scripting to make our lives easier, and we can just solve it using T-Shark. So this, again, T feels E. So again, we're saying the same thing. We're saying UDP, the protocol is UDP, and the destination port is 22. grep for the 5,000, so grep for the 5,000, and then this is a function of Linux, and print that from in the destination, or sorry, the source port from 0 to 5,000, and then echo it out. So there's a resource to understand better how this script and this command works, which is linked. But for T-Shark, there's going to be some scripting required to make it work properly. So let's go back into here. And if we paste that, it should give us the flag. It's going to append all of the separate characters because everything is being transmitted, I think, by character. So it's doing that squiggly thing, then P, then I, then C, then O. So we're going to, with the script, we're going to cause it to print it out all together. And so after we do that, we have our flag right here. So you can use this script. This problem showed up in a couple others. So if you don't understand, you can just run the script and you could save it to use for this year, maybe if they'll have a similar problem. Or you could try to understand how scripting works if you like. There's great resources on the Pico primer that's encouraged for everybody to review. So we solved it using T-Shark. So I'd like you guys to try, if you're comfortable, try solving it with this script. What you're going to do is, let's go back. What you're going to do is you're going to put this in a Python file. So what you're going to do is you're going to create a script. Let's call it T-Shark. Oh, there's already one that's called T-Shark. Let's call it tshark2.py. You're going to paste this into here. You just have to paste it and you're going to save it. I'm not going to be able to run the script because I didn't download Scapy, but you can get Scapy from GitHub using wget, get that into your decompress it, download it, and then run that script. You can do that in the web shell that's on picoctf.org or the 2019 web shell. For me, the 2019 web shell gives me problem downloading programs, so I like to use the picoctf.org web shell. But then for that, to get all of the materials, you're going to have to use wget to download them all into that location. So that was how we would solve Shark on Wire. And what the problem was, we were given just a packet capture that we had to analyze. So now let's talk about SSL dump. What is SSL dump? So SSL dump, so we talked about the two protocols. We talked about TCP and UDP, but there's also a secure socket layer or transport layer security, which is, which is when we're using HTTPS, our connection to the internet is being encrypted through that secure socket layer. So we can imagine that all like HTTPS traffic, would be through that layer. So SSL dump is an SSL TLS network protocol analyzer. So it's similar to Wireshark and it's similar to T-Shark, but it's analyzing SSL TLS network traffic. It identifies TCP connections on the chosen network interface and attempts to interpret them as SSL or TLS traffic. And there's more information about this using this link right here if anyone wants to read more detailed into it. But it's kind of like a tool like Wireshark, T-Shark, but it's analyzing SSL traffic. So let's go to our problem, which is called WebNet 01. So it's saying we found this packet capture and key, recover the flag. You can also find the file in problems.this. Okay. So it's saying try using a tool like Wireshark. How can you decrypt the TLS stream? So when I Googled decrypting the TLS stream, I came across the SSL dump tool, which is why I decided to use the SSL dump tool. You can use a tool like Wireshark or Tshark or TCP dump to solve this problem, but it might be a lot more trickier. The solution I'm going to show you is super easy. So we have a packet capture and we have a key. So let's download the packet capture by copying the link address. Let's clear this up and make it a lot nicer. Let's make a new directory for this, and this was called webnet 0. And let's cd into, oops, okay, let's go back. I made this in the wrong place. Let's make this directory here, webnet 0. And oops, cd webnet 0, we don't want that, crazy. Okay, so here we have nothing, so we're in the right directory. So in this directory, let's get that location, paste selection. Okay, so now we have that packet capture. And let's also get the key. It looks like it's going to be a decryption key. Copy link address, wget, same thing, just gonna get that, paste selection. Okay, ls to see that we have both. So now we have our pico.key, and we have our packet capture file. So now let's analyze what we need to do. So for SSL dump, you can use a simple method. So -r is similar to Tshark. It's saying to read the file, and -k and pico is the key, and -d stands for decrypt. So all we're doing is we're using this, oops, we're using this command right here, using SSL dump to decrypt the key. That's pretty much all we're doing. We're reading the packet capture, and we're decrypting it using this SSL dump key. So let's go back and let's paste that right into here. We're going to use SSL dump. Most likely it will be installed on the web shell, but if it's not, you would use the sudo apt install. I will scroll, and right here is the Pico flag. This is the flag right here. And so this is a packet capture file, but it's been decrypted. We're using the key that we had. If we didn't have the key and this was encrypted, it wouldn't have been able to, it would have just looked like this. Like this one was not able to decrypt. It just looks like a bunch of random things. We wouldn't know what it is without the key. So that was really easy, right? Without SSL dump, it would have been a lot trickier to use Wireshark or Tshark to solve that problem, and SSL dump just made it very easy for us to solve. So that is it for today. So let's talk about our summary of learnings. And this is from to get today and last time. So it's important to collect evidence after an incident and to make sure volatile evidence is captured first and not lost. First time we talked about numbering systems, and today we took a look again on the importance of converting from hex to ASCII and understanding that, because when we're looking at packet captures, you most likely will have to convert. File headers we talked about last time. If you ever want to view binary files for some of the problems, it's important to use hex editors. You can use online hex editors, or you can download a hex editor. And steganography allows us to hide the fact that we are sending a message. And Wireshark and Wireshark, Tshark, SSL dump, TCP dump allow us to capture and analyze network traffic. And we learned about Wireshark last time. This time we talked about Tshark and SSL dump. So here's some resources that you can utilize, and we will share them on the resource hub. And that is it for today. So we're here for questions. Thank you for your time. It's a reminder to just register for the next Wednesday's workshop, which is on jobs in cyber. So please make sure that you've registered for that workshop. Students and the teachers and the parents and the supervisors, everyone who wants to attend will need to register. After this workshop, I will be sending an email. So please do forward that off to the students as well. So that is it for today. Please let me know if you have any questions. And if not, then please feel free to leave and enjoy the rest of your evening.